My name is Vadim, and I work at the University of Oulu as a mathematician helping roboticists and virtual reality researchers to develop mathematical models. I'm also the founder of Manifold Solutions, and today is 25 days left until IB first math paper, to which this video is going to help you to prepare. My gift to you is for free, and another gift is that if you go to the description of this video, you'll find a link to my live sessions, which are also practically free, where you can join and ask me questions, interrupt me when I'm doing mathematics, and propose problems that you want me to analyze together with you. Stay tuned. Okay, welcome to IB Math Prep. In this video, I am going to go through a geometry exercise. So yeah, let's dive in without further ado. Let's move myself, and here we are. Okay, so we have a sector. It has two sides which are equal to the radius of the big circle from which this sector has been cut from, a pizza slice if you will. And then we have a smaller circle which is inscribed in this sector. These sides here are tangent to this circle, and the radius of the small circle is r, and this angle here is 2 alpha. And the first question in this exercise is to determine the area of a DOE, the quadrilateral. So yeah, this area here. Now we can intuitively immediately see that that area is composed out of two triangles. So if we draw an imaginary line from A to O, we see that this is composed of two triangles. Now officially we would have to explain or show why these triangles are really equal in area in order to use that information, and the explanation is that they are similar. Why are they similar? All of their sides can be matched and their angles can be matched. Let's see, how do we do that? First of all, we realize that this O has equal distance to E and O because that distance is equal to the radius of that small circle. So these sides are equal in these two triangles. Then this side, the hypotenuse of the right angle triangle, this right angle triangle, this right angle triangle. By the way, the tangent is always at a right angle to the radius of a circle. This is general knowledge. I guess that's basic properties of circles, if you will. And so these are the same. They both have a right angle over there, and so now you can already, from that information, you can solve using the Pythagorean theorem. You could solve the third size, which will then be the same in both triangles, which also means that this angle is split into half by the hypotenuse. Okay, in fact, in the exercise, it's not just given area of that quadrilateral. It actually says that show that the area is of this form, r squared divided by tangent alpha. Now this is helpful because it kind of gives us an answer, and all you have to do is to prove that this is the case. It also gives a hint as to what's the kind of most compact representation, because you could solve the area in many different ways and you might get very complicated looking formulas, but in this exercise the formula is kind of given, and so yeah, it makes stuff easier. Okay, so now if I'm gonna reproduce this triangle over here, something like this, here R, and this is alpha. Now, how do I get the area of such a right angle triangle? The area of a right angle triangle, if I denote this side by h, because it's kind of the height of the triangle, if I'm looking at it a little bit tilted, then the area of that triangle is h times r divided by 2. How do I know h? Well, we know. Well, now we use this hint. The exercise gave us a hint, and we know that tangent alpha is actually the opposite side of alpha divided by the adjacent side. Okay, so that's the tangent, and if we now want to use that to obtain this, well, there are many ways you can go about it, but basically this most straightforward way is to look at this expression, which was already given in the exercise, and just substitute this expression and into this denominator, and show that we eventually get the correct expression for the area, but not of the triangle. Remember that we are actually looking for the area of this quadrilateral, and the area of the quadrilateral obviously is going to be double this, so it's going to be just, let me put it somewhere here, h times r. So that's going to be the area of the quadrilateral. So by substituting this this there, I'm expecting to get h times r, and this will prove my point. Okay, r squared divided by r divided by h. Well, easy peasy. I mean, r's cancel. I mean, the second power cancels this r, and the h is there. Now it comes back up, and we got what we wanted. So that's the first part of this exercise. For the second part of this exercise, there's another picture which I'm going to show you in a minute. I'm going to take this out, and instead I'm going to bring in this picture. Now let me check what they actually ask in the exercise. Alright, so they're asking first for the angle EOD. Angle EOD. And then they ask to find out the area which is shaded, which is R. And the way the exercise is framed is that find the angle and then hence or otherwise find the area R. That means that they assume that it's probably the easiest for you to use this this knowledge, that angle, to derive the area R. But if you do it some other way, you still get full points. That's what it means when it says hence or otherwise. You probably know that anyway. Okay, so what's the angle EOD? Since we just realized that we have a right angle triangle, we can use that. We can continue using that idea. So this triangle, which we just had here, gives us a hint. We know that the sum of all angles of a triangle is always equal to pi, So in this case, because this is right angles, is half pi. So we know that alpha plus half pi plus this, let's denote it by beta, which is this angle. That must be equal to pi. Oh, sorry. This angle is not beta, this angle is beta times 2. But our beta is now this small angle. We could also use the fact that the sum of all angles of a quadrilateral is 360 degrees, but it doesn't matter. I mean, I'm going this way because I wouldn't be sure if you can use the fact that the sum of all angles of a quadrilateral is always 2 pi. Did I say 2 pi? I was supposed to say 2 pi. But the fact that the sum of all angles of a triangle is equal to pi, that's general knowledge. That's like something I assume in IB exam you don't have to explain, you can just use it. So let's use that. So from here we can solve that beta will be equal to half pi minus alpha, and so this will be double that, so EOD will be pi minus 2 alpha, which makes a lot of sense. You can also actually realize this because okay, so we just proved it. I mean, that's how you see it. Okay, so now once we have this, we can calculate the area of this sector, and we can subtract it from the quadrilateral that we previously, whose area we previously figured out that it was equal to r squared divided by tangent alpha. And so when we subtract from that the area of this sector, then we get that shaded area. How do we get the area of this sector? We already know this angle is this pi minus 2 alpha, and when we know the angle of a sector, then we know immediately that the area of that sector, the proportion it takes out from the entire disk, is exactly the same as the proportion of that angle compared to the full angle. So you know, what is the pizza slice? You know, the size of the pizza slice is proportionate to the angle at which you cut, right? A small angle, you get a tiny thin pizza slice, and with a large angle you get a big pizza slice, and so on and so forth. And so in this case, pi minus 2 alpha divided by 2 pi, this is the proportion, and the area of the entire disk with radius r is pi r squared. That's probably in the formula booklet. Let's check just for fun. Do we have it? Do we have it in our beautiful formula booklet? Let me take one of my cursors away. I have too many. So let's scroll to geometry. Distance of a point. Here we have a lot of those. Okay, so volume of a cone, a pyramid, area of the curved surface of a cone. That's very complicated stuff. Surface of a sphere, area of a triangle, length of an arc, area of a second. But no area of a disk. Well, I guess you're supposed to know it. See? don't rely on the formula booklet too much. The stuff you gotta know. Oh, I'm sorry. Okay, I didn't realize I didn't see this before. Okay, indeed. So in case you missed it, AOD has to be equal to pi minus 2 alpha, which was solved from having beta equal to pi half pi minus alpha, which we got in turn from the idea that all the angles of a triangle sum up to pi. And so now we have this fraction, so the proportion of how much that angle takes up, this angle, how much it takes up from this disk, that's how much this sector area takes out from the entire disk. And the area of a disk is pi r squared, and when we multiply it like this, okay, those pi's cancel, and so we have pi minus 2 alpha divided by 2 r squared. And this hardly simplifies. So let's see if we what happens when we subtract this from the area of the quadrilateral ADOE, because that's going to be the area which we're looking for. So area of R, well, it just is R. Okay, R is the shaded area. Is the area of the quadrilateral which we obtained in the previous part of the exercise, which is tangent with its r squared divided by tangent alpha, and from this we subtract the area of the sector from O to E to D, and that sector is given above, so we subtract like so. And now we just have to simplify this expression. Not sure how much is possible to simplify, but let's try. So let's expand the left one by 2, and also this one we expand by tangent. Nah, I really don't think it makes any sense to try to bring it into any other form. So actually, let's go back. Oh, wait a minute. Here we are. This is our answer. Okay, there is a third part in this exercise. Okay, here is the third part of this exercise. It asks, find the value of alpha for which the area of R is equal to the area of the circle of center O and radius R, small r. Okay, so I mean, in a you can look at it in a boring way and you just say, okay, let's write the expression and solve it. So, and that's what you probably should do at the exam, not think about it too much. But if you have some intuition, it might help you not to make some mistakes, you know. But anyway, the most blunt and boring approach is to write exactly what they say. So find the value of where the area is equal to the area of the circle. So the area is this R, and we should write an equation which says that R equals the area of the circle, which we just previously realized was pi r squared. So the equation becomes, let me just copy paste this here, and this is equal to pi r squared, and from this we just should simply solve alpha. So there is a sweet spot in the middle where you find the exact angle where this disk's area matches exactly this shaded area, which is kind of fun that you can mathematically, find that point. It's not obvious, like today in machine learning applications and deep learning and stuff, most of the time they don't know how to find exact solutions to anything. That's why they're applying this kind of very heavy machinery to search for approximate solutions. But sometimes, like in this classic geometry setting, you can still find the exact solutions, and that's kind of pleasing. Let's move on and actually find the solution. Can talk a lot, but that doesn't help at the exam. Okay, so let's put this equation here. Let's move this exercise there. And okay, let's jump in. Okay, so where should we start? We need to solve alpha. I mean, I'm seeing a problem here already, because we have both tan alpha, and when you have tan alpha and alpha in the same equation, it's kind of scary. It's like, are you sure you can actually solve this? Because very often equations of the form, alpha equals tan alpha, that's a very difficult equation. I'm not sure if I know how to solve it, but let's try. So the first thing is just bring all alphas on one side and everything is the other side. Another thing, by the way, we notice immediately these small r's, they cancel right away. Namely, if we just divide by r squared, and this goes out, this goes out, and this goes out. So we are left with a much simpler equation, which is 1 divided by tangent alpha minus pi. Oh, let's expand this in this way. So I divided pi by 2 and 2 alpha also by 2. And this minus becomes plus, because we can imagine brackets over here. And then on this side we just have pi. Very interesting. What do we have here? Wow, what an equation. So, okay, let's do what we were supposed to do. So let's move pi, let's put it plus pi plus half pi, and we have, and let's transform tangent into what it really is, which is sine alpha by cos alpha, and so it's inverse, so it's the opposite. So this is just cos alpha divided by sine alpha plus alpha, and this is equal to 3 pi by 2. That's very interesting. That's very interesting. How on earth are you going to solve that? What? Okay, this is not going to work. This expression is too difficult. We have to think about some other way to solve this. Okay, so let's look geometrically at this. What happens when this, wait a minute, when this disk is equal to that r, that means, wait a minute, disk is equal the area of the disk. Okay, I got it. This is paper 2 question. So it's allowed to use a calculator. Well, then you just plug this into the calculator and you get the solution for alpha. This is exactly the type of equation I just basically said previously. Right? I said something like alpha plus tan alpha is something. That kind of equation you can't solve analytically. But if you have a graphic calculator, you just plug in and it gives you a solution. Let's try. Okay, so I have here a calculator online, which I'm not sure if it's the same type as you guys have in your exam, but bear with me. Okay, so here is an online calculator I found. I'm not sure if it has anything to do with the one that you guys are allowed to use in your exams, but this is reasonably similar, I think. So what I did, I first solved this equation and I got many solutions, a lot of solutions, and then I plotted this function just to see what it looks like. Sorry. And since tangent has many branches, as we all know, this function also is like this. And that's the reason it actually has probably like infinitely many solutions, because if you draw the line at 3 pi divided by 2, somewhere around here, then around 3 pi divided by somewhere around here. Anyway, so it crosses these tangent graphs infinitely often. Now, we're interested in a solution which is between 0 and between 0 and half pi, because we are solving for alpha, and in this picture, as you recall, we are having 2 alpha, and it doesn't make any sense to have this angle bigger than the flat angle, because then you cannot inscribe this circle in any reasonable way. So let's see which one of these solutions is actually between 0 and half 0 and half pi. Well, half pi is less than 2, and we can see that in fact only one of these solutions, namely this one here, is between 0 and 2. All the other ones, these are all negative, and these are in increasing order, so the ones below this are all negative, and the one above it is already 4, which is larger than pi. So the solution would be this one here, and yeah, you're gonna give at least 3 decimal points precision. You can round it up afterwards. Okay. Okay, so that was that. If you like looking at me solving these exercises, then subscribe or check the description of this video, where I have a link to my live sessions where I coach people to do better at the IB exams, which are coming up very soon. So hurry up.